Hello everyone. Title of this video is Section 6.4 Part 1 on a review of factoring. So this will be about factoring polynomials. And in this video I'm going to be going over a version of your Knewton Alta assignment for Section 6.4 Part 1. Please understand that the questions I'm going to be seeing in this video are not necessarily, going to be the exact same questions you'll see when you work on the assignment yourself. All right, but the objectives will be the same. The types of questions and how you do them will be the same. So hopefully watching me go through these will help you in some way when you work on the assignment yourself. And of course, I'm assuming you've done other reading and other video watching and note taking and practicing before this, so this is just kind of extra. Right. So here's your assignment, right? And you're not going to see the word preview. You'll just see the title, the mastery bar telling you how far along you've gotten. The objectives, it looks like there are 3 topics here with 6 objectives total. So this is a bit of a longer assignment. All right, 6 objectives, 1 objective under this topic, 2 under this topic on factoring special products, and 3 under the topic of factoring trinomials. All right. So and then you have your question and then your feedback button if you want to send Knewton any feedback about a particular question or topic that you're having trouble with, or tell them, hey, this question looks wrong, or they had a typographical error or something like that. You will not be seeing the instructor cheat button. Right, that's just for me. And you will see the more instruction button. Right, this is something you can open if you're struggling on a question or a particular objective, and you'll see further reading material or videos that'll hopefully help you with that objective. Alright, so we are asked to factor, this is in the objective in question 1 here. The objective is factor polynomials by grouping. Alright, so we factor polynomials that have more than 3 terms. So you see how this polynomial has 4 terms the way it's written, right? The u squared, negative 9u, negative 2u, and then positive 18. Right? And the way we typically do factoring by grouping is by grouping in halves, right? Breaking up the 4 terms into 2 terms plus 2 terms, and I'll show you that on some paper as I go through and factor this by grouping. So as I said, we typically will attempt to factor by grouping if there are more than 3 terms, which we are seeing here. The way, as I said, the way this is written, there are 4 terms. So the first thing in grouping with 4-term polynomials anyway is to do the grouping. Right? So here's the grouping stage, and what I'm going to do is you can group it, you can group 3 terms in 1 term, or 2 terms in 2 terms, or 1 term in 3 terms. Typically for the 4-term polynomials like this, we're going to group 2 and 2. So in one grouping set, grouping symbols are parentheses or brackets, but I'll use parentheses. And in the first group, I'll put the first 2 terms, u squared and negative 9u, right? U squared minus 9u. And then I like to put a big plus sign. We're going to write the original expression as a sum of 2 groups of terms. The first 2 terms in the first group and then another group, another set of parentheses, and then the next two terms, negative 2u and the positive 18, right, plus 18 in the second group, right? So there's the grouping stage, right? Then we factor each group individually, right? Factor each group. So if you look at the first group, u squared minus 9u, right? Well, when you factor, right, I guess I should have said it in the beginning, but the first thing you should look for when factoring anything is the greatest common factor, sometimes referred to as the GCF. And that's what I'm doing here. Right? What's the largest number, the largest expression that goes into both terms evenly, that is a factor of both terms, or all the terms? There was nothing that was a factor of all four terms, but there is something that's a factor of just these two in this first group, and that would be u. Alright, so then I pull out the factor of u, and it's just like reversing the distributive property. If I pull out a factor of u, the factor remaining would be u minus 9. And you can double check your factoring by multiplying. Multiply u by u, you get u squared, and u by negative 9, you get negative 9u. So this is the good factoring there. Alright, then I got plus. Alright, then over in this second group, the negative 2u plus 18, notice that in this group, the lead coefficient is negative. And when that is the case, when the lead coefficient is negative, it's typical, it's useful, something that's commonly done, to not pull out the greatest common factor, but pull out the opposite of the greatest common factor. So we're going to factor out the opposite of the greatest common factor. And, negative GCF. If the lead is negative, pull out a negative. All right. So in this group here, negative 2u plus 18, the greatest common factor is just 2. But we're pulling out the opposite of this, right? That's why I'm going to throw minus. So I'm going to factor, because the lead coefficient is negative, I'm going to factor out negative 2. So we got negative 2 pulled out. And if I remove negative 2, the remaining factor would be u minus 9. And go ahead and check with multiplication. Negative 2 times u, negative 2u. Negative 2 times negative 9, positive 18. So this is the proper factorization. Alright, then after you factor each group, you factor the entire expression, if possible. Right? Do you notice how after I factored out the u from the first group and the negative 2 from the second group, that other factor is common now to both the first product and the second product, right? U minus 9, U minus 9. So we can factor the whole expression now, factor the entire expression. And I'll say, if possible here, because there are polynomials with more than 3 terms that are not factorable by grouping. But yeah, now look at the expression as a whole. You got this first product plus this second product. There is a greatest common factor for both of these. Both of these have a common factor of u minus 9. This quantity u minus 9. Right? So I'm going to factor that out. So I have the quantity u minus 9 is its own factor. And then the factor that remains when I remove pull out, factor out u minus 9, would be u left over in the first term plus negative 2. Now you can write plus negative 2, that's not wrong, but usually plus a negative is just subtraction, so minus 2. And there we go. There is the original expression completely factored. Right? Remember, factoring means writing as a product. So my original expression is just one big sum, right? U squared plus negative 9u plus negative 2u plus 18. The final expression is a product. One factor times another factor, right? That's what factoring means. Write the original expression as a product. And then, of course, check your result by multiplying. That's how you check if your factoring was correct. So you take, I've got my final result, the factored version was, u minus 9 times u minus 2. Sorry, u minus 2. And let's multiply. Now, I'm hoping you know how to multiply polynomials. You just take every term from one polynomial and distribute to the other. All right, so let's distribute the u to the u minus 2 first. That gives me u squared minus 2u. And now I'm done with the u. Move over to the negative 9 and distribute the negative 9 to the u minus 2. That'll give me minus 9u and then plus 18. And you see how these four terms, you have u squared, the original had u squared. Negative 2u, the original had negative 2u. Negative 9u, the original had negative 9u, and positive 18, the original had positive 18. So this is the same as the original expression, right? And it should be. Okay, if you factored completely and then you want to check, did I do it right? Multiply what you have properly and see if you get the original expression back. And if you did everything correctly and you know how to multiply properly, you should get the original expression back. All right, so this is what I'm going to enter. All right, the factor, u minus 9 times u minus 2 back in the assignment here. So in parentheses, right, u minus 9, close parentheses, times, and then the quantity u minus 2. Right. Okay. And again, it doesn't matter what order these come in. It could be u minus 9 times u minus 2 or u minus 2 times u minus 9. Right? When you have a product of factors, it doesn't matter what order those factors come in when you're multiplying. These are all representing real numbers. Okay, wonderful. And after every question, whether you get it right or wrong, you have an answer explanation. Please read through this. All right. If you get it right, read through it to make sure you got it right for the right reasons and that you didn't just get lucky. If you got it wrong, read through it to see if you can figure out where you went wrong. And maybe you can learn from your mistakes and do better the next time. Okay. So next question. I think they're going to give us, because there's the different headings, right? They're, like I said when I showed you the objectives, right? There are the 3 different headings, and they'll keep you in one heading until it's complete before moving on to the next heading. So we're going to get 4 questions in a row here where we're factoring polynomials by grouping. All right, so I'm going to do this next one by grouping as well. I'll write it out and we'll do it on paper. All right, so same deal as the first example. There are 3, more than 3 terms. There are 4 terms in this polynomial here. So the first step is the grouping. Right? I group the first step should be to look, is there any common factor in all 4 terms, which there isn't. Then I start grouping. All right, the first group has, I'll put the first 2 terms. We have m times n, and then positive 7n. Right? First group. And again, I like to do this, put a big plus sign. We're writing this sum of 4 terms as a sum of 2 groups of 2 terms. And then another group with the second 2 terms in it, negative m, and then minus 7, right, negative 7. This left group, right, the first group, the greatest common factor is n. This second group, the greatest common factor, well, there isn't any, right? It's just 1. If there's no common factor, the common factor would be 1, right? 1 goes into everything. But just like in the first example, I'm noticing the lead coefficient here is negative, right? Negative 1m. So I'm going to be pulling out the opposite of the GCF. I'm going to be pulling out negative 1 from that second group. Alright, so factoring the first group, we pull out the common factor of n, and the factor remaining when I do that would be m plus 7. So this first group is n times the quantity m plus 7, plus, and then I'm pulling out the factor of negative 1 from this second group, and what's left over would be the quantity m plus 7. And then you look at the thing as a whole, right? Look at the entire expression now, after factoring both groups. The greatest common factor of both these products is this quantity m plus 7. So, I pull that out. Then we have the greatest common factor, m plus 7, and the remaining factor, when I remove the factor of m plus 7, would be n plus negative 1, which can be written as n minus 1. And that is a product. There is no plus sign between these. It's not a sum, right? It's the original expression written as a multiplication problem, right? As a product. Again, please check this by multiplying. Distribute the m to n minus 1, distribute the 7 to n minus 1, and you should get the same 4 terms that were in the original. So this is what I'm going to be entering. M plus 7 times n minus 1. So the quantity m plus 7, parentheses, n minus 1. Okay. And submit. Wonderful. And again, please read through the answer explanations. Alright. Another one where we're factoring by grouping. So I'm going to write this out and do it on paper. So yet again, we have a polynomial with 4 terms. So first I'm going to write it as a sum of 2 groups with 2 terms. First group will have the first 2 terms. You have AB plus 10b. And then again, I like to put a big plus sign here. And then the second group has the second 2 terms, minus 1a, minus 10. Alright, then we factor each group separately, right? The first group, the greatest common factor of these 2 terms is just b. So that'll factor to b times the quantity a plus 10 plus, and then the second group, again, there's no common factor, other than negative 1, I guess, but the greatest common factor would be positive 1. But once again, like the first 2 questions, the lead coefficient in this group is negative. So I'm going to pull out the opposite of the GCF, right? Pull out negative 1. And when I factor out negative 1 from this second group, the remaining factor would again be a plus 10. And then looking at the entire expression now, both these products have a common factor, and that would be the greatest common factor of these products is that quantity a plus 10. So I'll remove this, right, the greatest common factor, a plus 10, And the factor remaining would be b plus negative 1, which should just be b minus 1. And there we go. This is what I'm going to enter. All right, there's the original expression written as just a product, right? No sums or differences. Yes, there's a sum inside that factor and a difference inside that factor, but as a whole, it is a product. It's multiplication. Right? And then, of course, again, check. Please check. Distribute the a to the b minus 1, distribute the 10 to the b minus 1, and you'll see the same four terms that we had originally. Alright, so I'm entering here a plus 10 times b minus 1. And be careful, make sure you're putting the proper letters and everything, because it will mark you wrong if you put incorrect letters. So just pay attention to what you're typing. Alright, and then read the answer explanations, please. Alright, then we probably have just one more here. Okay, very similar to the first question we saw. So again, I'm going to write this out, do it on some paper. Okay, so once again, the way this polynomial is written, it has four terms. Yes, I know you can combine these like terms and make it a polynomial with three terms, but there's a reason they're doing this, right? And you'll see later in the video, later in a later objective. Alright, so once again, a polynomial with written as four terms, the sum of four terms. I'm going to break it up as the sum of two groups of two terms. So in the first group, right, I'll have a squared and the negative 4a. Alright, then plus, and then the other group has the positive 6a and negative 24. Alright. So now I factor each group. The greatest common factor of this first group is just a. The greatest common factor of the second group is 6, and this time I don't have a negative lead coefficient. So I'm not going to pull out negative 6, I'm just going to straight up pull out 6. Alright, so factoring each group gives me the following. The first group factors to a times the quantity a minus 4, plus, and then the second group factors to 6 times the quantity a minus 4. And now that I've factored each group, when you look at the whole expression, both of these products have a common factor of a minus 4. So I'm going to factor out a minus 4. So I pull a minus 4 out, there's your one factor, and then after removing the factor of a minus 4, we're left with a plus 6 as the other factor. And there you go. There's the original expression written as a product. And please, I'll put a check mark next to it. Don't forget to check it. Distribute the a to the a plus 6, distribute the negative 4 to the a plus 6, and you'll see the exact same terms that you started off with. Alright, so that's what I'm going to enter here. So we had a minus 4 times a plus 6. And again, be careful with the letter you're typing. Some people accidentally put in X instead of A sometimes, and it'll mark you wrong. So be careful. Great. So one of the 6 objectives is completed, right? That factoring by grouping. And let's move on here. Alright, so now you see we're in the second heading on factoring special products. Nope, looks like, nope, sorry. They moved us down to this heading on factoring trinomials. That's the one that's lit up. So I'm going to be going through probably these 3 objectives next, and then we're going to go back here to these 2 objectives in factoring special products. So this question is on the objective, factor a trinomial with a leading coefficient of greater than 1 using what's called the AC method. Alright, so I'll describe the AC method for this first one, and then just keep using it every time this objective comes up again. Alright, so let me write this polynomial out. and do it on some paper. All right. So the first step you should do in any factoring is find the greatest common factor. And I've mentioned this out loud, I just didn't write it, but this is the first thing you should be looking for whenever factoring. So the greatest common factor of all three of these terms right now is 3. All right. That's the largest number expression that goes into all three terms evenly. All right, so I'm going to start off by factoring out a 3. All right, so if I pull out 3, we have 3 times, now 3 times 21 would be 63, so this gives me 21n squared, plus, and then 3 times 50 would be 150, so 50n, plus, and 3 times 25 is 75, right, so plus 25 there. Okay, so I've pulled, first thing is pull out the GCF. Now we're focusing on this polynomial. Right, the greatest common factor, great, that's out now. Now we're going to focus on this. So let's say focus on this remaining factor, because we're asked to factor completely. So we need to know, is this, called a quadratic polynomial, because you have n squared as the highest power of n there. Is this factorable? So now we're looking at polynomials of this form, a times, now I'm going to use x over here, but just know that the variable, or it could be any expression, x, n, right? Ax squared plus bx plus c, where a, b, and c are numbers, right, like 21, 50, and 25. All right. So the first question I want to ask for a polynomial like this is this factorable? Is this even factorable? Can I break it up? And whenever I say factorable, I mean factorable over the integers, meaning all the coefficients are integers. No, I don't want fraction coefficients or any other coefficients, right? So that's what I mean when I say factorable. Now, this method I'm going to put up for you here. This is not mentioned in our text, so this is actually, again, you don't have to do this, but I like to use the b squared minus 4ac method. Now this just tells me if it's factorable or not. This doesn't tell me how to factor it. But if you calculate this, and if this b squared minus 4ac, if this is a perfect square, then it is factorable. Right? Then the polynomial is factorable. Now, by perfect square, I mean 1 squared. Is it 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, right? Is it an integer, a whole number squared? Okay. So b squared minus 4ac here would be 50 squared, right? B is always the coefficient of the first powered term, minus 4 times a is the coefficient of the squared term, so 21, times c is always the constant, the final coefficient there, 25. Alright, you know what? I don't need a calculator for this. This is 2500 minus, and then 4 times 25 is 100, so this is 2100. And I'm left with 400 here, which is 20 squared. That is a perfect square, 400. Now you could use a square root, put in a calculator and then take the square root, and if the square root ends up being a whole number, then you're good. If not, then this trinomial is not factorable. So the answer is yes. Right? This is factorable. So now that it's factorable, I'm going to use what's called, the AC method for factoring. All right, the AC method. Alright, so so this is separate. This is just, is it factorable? You know, these ax squared, an squared plus bn squared plus bn plus c, or ax squared plus bx plus c. I just wanted to know if it was factorable or not. You know, should I even waste my time trying to factor it? And you know, the answer is yes. B squared minus 4ac was a perfect square. All right. So first, you find a times c. A times c, which in this case would be 21 times 25. All right, 21 times 25. Now that would be 425. All right, 425. All right, yeah, because 20. Nope. 525. My. All right. Yeah, because 2 times 25 would be 50. 20 times 25 would be 500. Yeah, 525. My apologies. All right. All right. So I found AC. Next. Now this is probably the trickiest part. Find a pair of factors of AC whose sum is B. So I'm trying to find a pair of factors, right? Numbers that multiply to be 525 but add up to be positive 50. All right, so you could do this if you wished. Right? I'm going to make a little table, a little chart. Factors of 525 and then their sum. Right. Now, to make positive 525, you know, I need both numbers to be positive or both numbers to be negative, right? Because negative times negative is positive. But I want the sum to be positive. So both numbers need to be positive. So I'll start. I mean, you don't have to do this. I mean, if you see the factors already, then use them. But you know, obviously 1 goes in everything. 1 times 525 would be 525, and I'm only doing this for this first example. All right, later on I'll probably see them. I already see it, but you'll see them more quickly. Add them together, you get 526. No, right? That's a no on that one. I want a sum of positive 50. 2 doesn't go into this. 3 does, right? You know, add up the digits, it's 12. That's 3 times 175, right, would be 525. Yeah, 175. And then this adds up to 178. Smaller, closer to 50, but still not 50. So no on that. All right, 4 doesn't go into this. 5 does, right? Clearly 5 does. It ends in 5. So how about 5? Now that'd be 5 times 105 would be 525. Now you can use a calculator to do division, see what numbers, you know, go into numbers evenly if you want to make things a little faster. But these add up to 110, which is not 50, but we're getting closer. All right, so no on that. All right, now 6 doesn't go into this. 7, I'd have to check. Let's see, 490. No, 5. Yeah, 490 plus 35. 7 does go into this. All right. Yeah, 7 goes into 52. 7 times 49. 52 minus 9 would be 3. 35. So 7 times 70. 75. Right? Yeah, 490 plus 35 would be 525. Still, they only add up to 82. Getting closer. 8 doesn't go into this evenly. 9 doesn't go into this evenly. You know, sum of the digits is 12. That's not a multiple of 9. 10 doesn't. 11 doesn't. 12 doesn't. 13 doesn't. 15 would. right? Because 3 and 5 do. So 15. Let's see, 15 goes into 52 3 times. That'd be 45. And subtract 75. 15 goes into 75 5 times. And 15 and 35. There we are. Those add up to 50. Okay. So again, this is unnecessary. Sometimes you could use a calculator if you wish to see what the whole numbers go into a number evenly. But again, that's the second step though. After finding AC, then we're looking for a pair of factors of AC whose sum is B. Right, now, again, the future examples will hopefully will be shorter because I won't be writing all these steps out. Next step is rewrite B times X or B times N using this pair of factors. So I'm rewriting that linear term, the 50n, so we have 21n squared, right? 21n squared plus, and then 50n, I'm going to rewrite using these two factors here that add up to 50. 15n plus 35n, right? Because don't those make up 50n, right? 15n plus 35n is 50n. And then we have plus 25 as a constant term. And do you see what we've done? This looks kind of like problems from earlier when we were factoring by grouping. And that is the last step. After rewriting that middle term, factor by grouping, right? Because you'll have now a polynomial written as a 4-term polynomial, right? Breaking that middle term up into 2 terms makes it a 4-term polynomial, and then you can try grouping, factor by grouping. Alright, so as before, first group has 21n squared plus 15n, plus second group has 35n plus 25. Now I'm not going to write all the steps now for grouping. We've done grouping 4 times up to now. First group, the greatest common factor is 3n. Alright, so I'm pulling 3n out, leaving me with 7n plus 5 plus, and then second group, the greatest common factor is 5, and it's positive lead coefficient, so I'm just going to pull out 5. And what's left over would be 7n plus 5. And then you look at both of these products here. They have this common factor of 7n plus 5. Alright, so I pull out 7n plus 5. And if I remove 7n plus 5, the remaining factor is 3n plus 5. Alright, and check it. Distribute the 7n to the 3n plus 5. Distribute the 5 to the 3n plus 5, and then you'll get these 4 terms back, which make up 21n squared plus 50n plus 25. So great, I'm done. Alright. So now finally, we can write our final product. We started off with 63n squared plus 150n plus 75, right? We started off with that. I factored out 3 first. Right? Remember, the greatest common factor was 3. So I had 3 times, and then the 21n squared plus 50n plus 25. This factor factored even further to 7n plus 5 times 3n plus 5. Okay, and there you go. There's our original polynomial factored completely. Right, because these don't factor any further. And once again, I put a check mark there because you should be checking. When you multiply 7n plus 5 and 3n plus 5, you'll get 21n squared plus 50n plus 25, and then you would distribute the 3 to get 63n squared plus 150n plus 75. So this product does multiply to be the original expression, and this is what I'm going to be entering in the assignment. So we have 3 times, and then 7n plus 5 times 3n plus 5. And there we go. And that's what I'll submit. And again, please read through the answer explanations. Okay. And you see they did the same thing. But, I stopped when I actually had two factors that added up to what I wanted. They kept going. No need to do that. All right, moving on. Yeah, that was the AC method. All right, so here, still in factoring trinomials. This time, we're factoring trinomials with a lead coefficient of 1. So again, I'm going to write this polynomial out, and we'll factor it on a piece of paper. Okay, so notice that the lead coefficient is 1. So again, I'm factoring polynomials of this nature, trinomials, quadratic trinomials, ax squared plus bx plus c. But, a is 1. Right? A is positive 1. Here, b is the coefficient of x. The first power term is negative 10. Don't forget the negatives. And c here is negative 96. Again, don't forget that minus signs are parts of terms. So, you could still do the AC method. That method I did with the last example, and nothing changes. Right? You could still do this. So first to take a times c, which is just negative 96, right? Because 1, anything times 1 is itself. And then we try to find factors of negative 96 whose sum is negative 10, right? Negative 10. Now you could do the whole b squared minus 4ac thing like I did just to see if it's factorable. B squared would be 100, and then minus 4ac would be plus 96. 196 is 14 squared. So yes, this is factorable. B squared minus 4ac is a perfect square, but again, I don't think they'll be giving us too many problems where you're not going to be able to factor. All right. So again, you can start thinking of, now this time though, the number is a negative number, negative 96. So one factor's got to be negative, the other factor's got to be positive. All right, so I'll do this one more time, I guess. All right, I'll do this one more time. So I'll make a table, because this time we have, 1 has to be negative, 1 has to be positive. So factors of negative 96 and their sum, we're looking for a sum of negative 10. Now, again, we want the sum to be negative. So that means I want the negative factor to be larger, right? Have a larger magnitude. So I would want negative 96 and positive 1, right? Not the other way around. Because if the positive number had a larger magnitude, then the sum would be positive. But I don't want a positive sum. I want a negative sum. And these add up to negative 95, right? Which is no good. Then 2 goes into this. This would be negative. This is 2 times negative 48. It would make negative 96, and those add up to negative 46. Still no good, but we're getting closer to negative 10. 3 goes into this, right? 3 be negative 32. 3 times negative 32 would be negative 96. These add up to negative 29, which is still no good, right? It's not negative 10. 4 goes into this evenly, right? And this is 4 times negative 24. Right? Yeah, that'd be negative 96 when you multiply those. These add up to negative 20. Still no good. 5 doesn't go into this. 6 would, since 2 and 3 do. This would be 6 times negative 16. Right? And these are what I want. These add up to negative 10. Right? So what I'm going to do is rewrite the middle term. We have x squared, and I'm rewriting the minus 10x with these two numbers as, you could put plus 6x minus 16x, or I'm going to do it this way, minus 16x plus 6x. All right, rewriting the middle term with these two numbers, see minus 16 and positive 6. Right. And these make up negative 10x when you combine them. And then you have minus 96 at the end. All right, now we're factoring by grouping. So remember the first two in a group plus the second two in a group. That's kind of why I wrote the positive 1 second, so I could just put the groups in. First group factors to x times x minus 16, plus second group factors to 6 times x minus 16, and then these both have x minus 16 in common. So then I have x minus 16 pulled out times x plus 6. And there you go. And then check it by multiplying. Now, I'm going to tell you a little shortcut. Again, check it. Multiply these out, combine like terms, right? You should end up with x squared minus 10x minus 96. Now, here's a little shortcut for you. When factoring x squared plus bx plus c, you can see the lead coefficient is 1, right? 1x squared. Like we had here, a was 1. The factors will be this. It'll just be x in one of the factors, x in the other factor, like I have here. See, x here, x there. And then, I'll say x plus m times x plus n, where m times n equals c, and m plus n equals b. So basically, you have x in each of them, and then the numbers that you're adding to those x's are those factors we found. The factors of 1 times c, right? The factors of a times c here though is 1 times c, who add up to b. Right? The factors of negative 96 who add up to 10. So when the lead coefficient is 1, just go x plus a number times x plus another number, and those numbers are the factors that added up to that middle number, the factors of AC that added up to the b. Right? So you see how there's x plus 6, right? X plus the 6. The other factor is x plus negative 16, and that was the other number, right? So when this is only when the lead coefficient is 1, though, can you do this shortcut, right? Only when the lead coefficient is 1 can I just jump to the end like that. After finding this pair of factors, I could just jump to the end and say, oh, x plus 6 times x minus 16, and be done with it. But that's one more time, that's only when the lead coefficient is 1. Alright, so back here I'm going to enter my answer. X minus 16 times x plus 6. Or x plus 6 times x minus 16, doesn't matter. Okay. So hopefully you're seeing here, right, they did the same thing, right, where, see, they found, 6 and negative 16, and then they just jumped to the end, right, without doing the grouping, because the lead coefficient was 1, and you can do that in that case, and only that case. All right. So there's another one where I'm using, now again, you can use the AC method for all of these quadratic trinomials, ax squared, a number times x squared plus a number times x plus a number, right? Ax squared plus bx plus c. You can use this AC method for all of these if you want, right? not just when they're telling you to. All right, so once again, I'm going to write out this polynomial here. Now this time the variable is not x, it's n. Right, just again, be aware of that. You still do it the same way as if it were x, just make sure you're typing in the letter n in your answer. All right. So again, the AC method. Now here, a times c is 8. Right, the coefficient of the square times negative 35. Don't forget negatives are part of the terms, right? All right, now 8 times negative 35, that'd be negative 8 times 30 would be 240. 8 times 5 would be 40. So negative 280. All right, negative 280. Yeah, and then we're trying to find a pair of factors that multiply, factors of negative 280 that add up to negative 6. I'll do this one more time. Maybe I'll just do it each time. I don't know. Factors and their sum. And once again, I want the sum to be negative 6. One factor has to be positive, one factor has to be negative, and I want the sum to be negative. So the negative number needs to be bigger, right? Have a bigger magnitude, a bigger absolute value. So what I'll start with is negative 28 and 10. That's the obvious one. Now those add up to negative 18, which is no good. Alright, so then I'll just start cranking up the positive one here. Now 11 doesn't go into this. 12 wouldn't, because 3 doesn't go into this. 13. 260 plus 20. Now 13 doesn't. 14 would. Alright, 14 would. Oh, goodness, yes, of course. Negative 20 and 14. Wow, 2 times 14, 28. Yeah. Negative 20 and 14, those add up to negative 6. So here's the numbers I want. All right, negative 20 and positive 14. Those multiply to be negative 280 and add up to be negative 6. So now I'm going to rewrite the expression, where I'm rewriting this negative 6n using minus 20 and positive 14. Now don't just write n minus 20, n plus 14 like I did in the last example, right? The lead coefficient is not 1, so I can't just say, oh, this is n minus 20 times n plus 14. It's not that simple. I'm going to group, we have 8n squared, then again this minus 6n here, rewriting as minus 20n plus 14n. And then we have the minus 35 still. Right. Now again, the reason I'm writing the positive second is so I can do the grouping right here. First group plus second group. Right. With the minus in the middle, it's a little trickier. And then the first group, those have a common factor of 4n. And then you'd have 2n minus 5 left over. Plus, and then second group, have a common factor of 7, and then you'd have 2n minus 5 left over, and both these products have 2n minus 5, and when I remove 2n minus 5 you got 4n plus 7 left. Alright, and here you go. That's our factorization, and please check it. I'll put a check next to it. Distribute the 2n to the 4n plus 7. Distribute the negative 5 to the 4n plus 7. You'll get this. And then combine like terms and you get the original expression. I promise you. Right. But you should be checking your final result. Multiplying it out. Seeing if you get the original expression back. Alright, so 2n minus 5 times and then 4n plus 7. Again, please be careful to enter the correct variable. Pay attention. Wonderful. So they go through all the factors. Jeez. Right. Yeah. Again, if you see it early, like I did, you don't have to list all the freaking factors. Right. All right. Moving on. So now here is a factor of trinomial with a leading coefficient greater than 1 using trial and error. Now, trial and error just means guessing and checking. All right, trial and error just means guessing and checking. I don't like that, personally. So I'm just going to use the AC method again. All right, so I'm going to write this out and do the AC method again. Now, this one has two variables, but notice how it's quadratic in m and in n. You have m squared, m to the first, no m. And then going right to left, you have n squared, n to the first, no n. You can use the AC method for the following. To try factoring, you can use the AC method to try. Again, I say try factoring because some aren't factorable. Some are going to be prime, but a times x squared plus b times x plus c, which we've seen with one variable, or ax squared plus bxy plus cy squared, with two variables, which this takes on that form. It's just instead of x and y, I've got m and n. But either one of these, you can try factoring using this AC method, as long as they're written this way, right? Where the powers of one variable are decreasing and the powers of the other one are increasing. Right. So AC here is 4, right, the coefficient of m squared, times negative 3, right, the coefficient of the n squared at the end, right, AC. That's negative 12. And then I'm thinking of what are factors of negative 12 that add up to positive 4, add up to b, the coefficient of the xy or mn here. Well, that would be positive 6 and negative 2. Negative 2, positive 6, right? Those multiply to be negative 12 and they add up to be positive 4. So there I didn't even make a little table, I could just see it right away. All right, and then just like before, the lead coefficient is not 1. So now I'm going to do grouping. All right, we'll rewrite this as 4m squared, and then rewriting the middle term, right? Rewriting the middle term using these two numbers. 4mn is minus 2mn plus 6mn. And then we have the minus 3n squared. And once again, the reason I put the plus 1 second is so I can easily do grouping here now. Group first group plus second group. All right, don't forget, if you have a minus there and you do this, you got to change the sign here. All right. But again, I usually don't like doing it. If there's a minus in the middle, I usually like rewriting it with a plus, as you saw in my other examples with grouping. The first group has a common factor of 2m. And if I pull that out, what's left would be 2m minus n, plus the second group has a common factor of 3n. And if I pull that out, we'd have 2m minus n. And then both of these products have the factor 2m minus n in common. So we have 2m minus n as one factor. And if I pull out 2m minus n, what's left over would be 2m plus 3n for the other factor, 2m plus 3n. And there you go. There is a product. There is the original expression factored. And don't forget to check it. Distribute the 2m to the 2m plus 3n. Then distribute the negative n to the 2m plus 3n. You'll get these terms, and then combine the middle two like terms, and you'll get the original. Right, this does work out. All right, so like I said, you can always use, for these trinomials that are quadratic in nature, that are of these two forms I've written here, any trinomials of these two forms, you can attempt to factor using this AC method. Yeah, me personally, I don't like trial and error myself, guessing and checking. Now you can, go ahead, but I don't personally like it, so I'm just going to keep using the AC method. All right, so back here, and just pay attention to the letters you're entering. First factor 2m minus n times second factor 2m plus 3n. Close parentheses. All right. and submit. And now look at their, now they'll explain guessing and checking here. See what they did? They're like, hey, let's go over all possible factors and see which ones give me what I want. And oh, look, it's this last one. Great. Like, I hate that, personally. Like I said, it works, obviously, it works eventually, but I don't know. I like the AC method, so I'm just going to keep using the AC method. If you like just plugging in a bunch of factors, the first terms of each of these should multiply to be 4m squared, right? And the second terms of both of these factors should multiply to be negative 3n squared. And then you're just trying to pick the numbers that are correct so that when you do the outer and inner products, they add up to 4mn. Right? That's what you're guessing here and checking, trial and error. But like I said, I'm going to just keep using the AC method. Okay. All right, so this one's one of the easier ones, right? Remember, when the lead coefficient is 1, should be pretty simple. All right, so I'll write this out. All right, so like I said, this is another one of those quadratic trinomials, right? AQ squared plus BQ plus C, but A equals 1. And remember, when A equals 1, real simple, right? A times C would just be C, right? Because it's 1 times C. So it's just going to be negative 70, right? And then you're looking for factors of negative 70 that have a sum of negative 9. All right? Factors of negative 70 that would have a sum of negative 9. That'd be negative 14 and positive 5. All right. And check it, right? Again, I'm just writing because I see it. If you see it right away, great. If not, make a table or use a calculator to help you out. Try to find those factors. But you see 5 times negative 14, that'd be negative 70. And then 5 plus negative 14 would be negative 9. So these are what I want. And since the lead coefficient was 1, I can jump right to the answer. There's going to be 2 factors here for this quadratic. One will have q, the other will have q, and then one of these will have minus 14, the other one will have plus 5, positive 5. And that's it. The factors are q minus 14 and q plus 5. And don't forget to check. Multiply these out, combine like terms, you should end up with q squared minus 9q minus 70. Once again, that is only done where I'm just putting these numbers into the factors. That is only done because the lead coefficient was 1. I know I've said that out loud several times, but I'm just going to write it here. That's the only reason I can do this. If the lead coefficient is not 1, then I'm going to try the AC method. Right, so back, that's what I'll enter here. Again, make sure you're putting q instead of x, right? Q minus 14 times q plus 5. Read the answer explanations, of course. Alright, so again, they're saying using trial and error. Like I've been telling you, I don't particularly care for trial and error, so I'm going to be using the AC. Well, first you find the greatest common factor. I know I haven't said that a lot, but the first thing you do all the time when factoring any polynomial is pulling out the greatest common factor and then seeing if the other factor can factor any further. Alright, so we'll be doing that here as well. Alright, so if you look at all 3 terms at the moment, right, the greatest common factor, 4 goes into all the coefficients evenly. That's the largest number. And all of them have at least m squared. Alright, so 4m squared is the greatest common factor. So I'll pull that out. If I factor out 4m squared, what's left over would be 9m squared minus 3m, and then minus 2. And you can double check by redistributing the 4m squared and see that you get those same terms back, and you should. Alright, so now the focus is on, the greatest common factor we're not going to worry about, so it's usually just a single term. Now we're going to focus on this trinomial, this quadratic trinomial here, 9m squared minus 3m minus 2. Right, so I'll write it separately here, 9m squared minus 3m minus 2. Now once again, I mean, you can do guessing and checking, trial and error. Totally fine. I'm just going to do AC method. Right? I prefer it. You don't again, if you like guessing and checking, fine. Nothing wrong with that. But that's 9 times negative 2 is negative 18. The factors of negative 18 that have a sum of negative 3 would be negative 6 and positive 3. Right? Those multiply to be negative 18. They add to be negative 3. So now I'm rewriting the middle term, right? So I have 9m squared, and then this minus 3m gets rewritten as minus 6m plus 3m, and then we have minus 2. And I do grouping, right? First group plus second group. First group has 3m as a common factor, and then I'd have 3m minus 2 left over. The second group has 1 as a common factor, right? Remember, if there's no common factor, then at least 1 goes into everything. So I'll put 1 here for now. You don't have to, but 1 just to let me know that 1 is the greatest common factor of this 3m minus 2. And then these both have 3m minus 2 as a common factor, so we have 3m minus 2 pulled out. And if I remove the 3m minus 2, the other factor is 3m plus 1. Right? And you can double check. Multiply these two together, you should get 9m squared minus 3m minus 2. And then don't forget, we had the 4m squared pulled out earlier. Alright, so there you go. That's the factorization, right, totally factored version of what we originally had. And again, you multiply these two, you'd get that, then you would multiply by 4m squared and get the original. They should be the same. Right. Okay, so that's what I'll enter. So we have 4, and again, don't forget the letters, proper letters, 4m squared times, and then 3m minus 2 times 3m plus 1. Okay. Again, see, they're doing the guessing and checking, and the yeah. All right. So once again, with the trial and error, but I'm not going to do that. All right, I'm still going to use the AC method. All right, so I'll write this out, work on it on some paper. All right, so before I do anything, right, is there a greatest common factor? All three terms, and there is. Right? All three terms have a common factor of 7. All right. 7 goes into all three. So I'm going to pull that out first. And if I remove a factor of 7, right, what's left over would be 9d squared minus 9d plus 2. All right, plus 2. Okay. Now I'm going to focus on that quadratic trinomial. Right. So I'll write it separately. Right. 9d squared minus 9d plus 2. And then I'll try the AC method. Right. AC is 9 times 2, that's 18. Positive 18. And I want to find factors of positive 18 that have a sum of negative 9. Now, that would be negative 6 and negative 3. Right? Those multiply to be positive 18. Right? Negative times negative is positive, and they add up to be negative 9. So now I'm going to do this. Right? We have 9d squared, and then we have minus 6d, and then you know me, I like to have a plus in the middle, plus negative 3d. So I can do grouping. Right? Negative 6d plus negative 3d would be negative 9d, and then you got plus 2. And I put, first group plus second group. The first group have a common factor of 3d, and what would be left over would be 3d minus 2. The second group, their greatest common factor is 1, but the lead coefficient is negative. So I'm going to pull out negative 1. So I'm just going to say minus 1, plus negative 1 will just be minus 1. And then the factor remaining would be 3d minus 2. And then both of these have 3d minus 2 in common. And if I remove 3d minus 2 as a common factor, the factor left over is 3d minus 1. And go ahead and test it out. Multiply these. You should get 9d squared minus 9d plus 2 left over. And then don't forget that we pulled out a 7 earlier. So there we go. The totally factored version of our original polynomial. And again, multiply these out. Check it out. Make sure that when you multiply these out properly and combine like terms, you get 63d squared minus 63d plus 14. And so here's what I'll enter. We got 7 times 3d minus 2. Again, don't forget to write the proper letter. 3d minus 1. Okay. Moving on. So looks like we have one last question here on the again, I'm just using AC all the time. Right, I know they say trial and error. Again, just using AC again. All right. So I'll write this out and we'll start factoring. All right. So all three terms do have a common factor. Pull that out first. Now I know 4 goes into this, but not 54. All right, 4 doesn't go into 54 evenly. But so the greatest common factor is 2. All right, they're at least all even. So I'll pull 2 out. And then the polynomial that we'll focus on next will be 8n squared minus 30n minus 27. Okay, so now we're focusing on this polynomial here, right? So I'm going to do the AC method. Again, you can use trial and error if you want. We have 8 times negative 27. Let's see, 8 times 20 is 160. 8 times 7 is 56. Alright, so 160 plus 56 is 216, negative 216. Yeah, 160 and 56. Right. Alright, now I'm trying to think of a pair of factors of negative 216 whose sum is negative 30. So I can't think of it off the top of my head right now. So let's make this little table. Now I know that negative 27 and 8 work. Right? They're right there. They make negative 216. But when you add these, this would be negative 19. Negative 19. So that's no good. I want negative 30. Let's see. Let me bump this up. Okay, no 9. 9 definitely goes into this. So we have 9 and 24, negative 24. These add up to negative 15. That's not as good. Maybe I should lower this. 7 doesn't go into this. Alright, well, this is 3 cubed and 2 cubed. Pull 3's off. Alright, I'm just going to pause it and think about it and come back when I have it. Sorry. Okay, so I thought about it for a second and came up with negative 36 and positive 6. That'd be 180 and 36 is 216. Negative 216. These multiply to be negative 216 and add up to be negative 30. So that's the pair of factors I want. So I'm going to rewrite this 8n squared minus 30n minus 27 as 8n squared minus 36n plus 6n. Alright, that's the minus 30n using these two numbers. And minus 27, then we can group. Alright, first group plus second group, first half plus second half. The first group have a greatest common factor of 4n, and that'd be multiplied by 2n minus 9, plus the second group have a common factor of 3 times 2n minus 9, and then the GCF of these two is 2n minus 9, and the other factor would be 4n plus 3. And then don't forget we pulled out that 2 from earlier, so that didn't go away. So this original expression factors to 2 times 2n minus 9 times 4n plus 3. And don't forget to check it. Alright, if I multiply these two, I'd get the 8n squared minus 30n minus 27, and then multiply by the 2, and you get the original expression back. It should work. They should be the same. Alright, so I'm entering the 2 times 2n minus 9 times 4n plus 3, and again, don't forget to use the correct letters, right? Don't always use x. Great, so 2 objectives are down now. Let's keep going. We're still in that heading about factoring trinomials, right? So here's another one with, now this one's just with the lead coefficient of 1. So this will be real simple. So I'm not even going to write this one out. I'm not even going to write this one out. Lead coefficient's 1. All we'd be looking for then are factors of positive 42 that have a sum of negative 17, and that would be negative 14 and negative 3. So in one factor I'll have x and negative 14. The other factor I'll have x and negative 3. And that's it. It's very, very simple when the lead coefficient is 1 for these quadratic trinomials. I'm hoping you understand this. And please check by multiplying these, and you should get the original expression back. Okay. So yeah, any more questions where the lead coefficient's 1 like that on these quadratic trinomials, I'm not even gonna write them out. Same thing here. Right, here's another question. Factor a trinomial with a lead coefficient of 1. So you see 1d squared minus 8d minus 33. Again, quadratic trinomial, lead coefficient 1. You're just looking for factors of negative 33, whose sum is negative 8. And that'd be negative 11 and positive 3. All right, so my factors, one's going to have d with negative 11, d minus 11. The other's going to have d with positive 3. Right, so d minus 11 times d plus 3. And again, please double check, multiply this out, and you should get the original expression back. Alright, so those should be easy. Right, I'm hoping. Alright, then we have probably a couple more where we use the AC method. Now, I know I've been using the AC method a bunch for the trial and error ones too. But yeah, so let's just keep doing it. Keep practicing this AC method. So these I'll actually write out. They take a little more steps. Alright, so once again, looking through all three terms, the greatest common factor is 1. Right? There's nothing really that goes into all three of these. So now I'm doing, I've got a quadratic trinomial in one of those forms that I mentioned. This is the one with one variable. So I take a times c, the 20 times 10, and that's 200. And now I'm looking for a pair of factors of 200 that add up to negative 33. Well, if that's the case, I need two negative numbers, right? Two negative numbers will multiply, pardon me, to be positive 200 and add up to be negative. Now, the obvious ones I'm looking at are negative 20 and negative 10, but those add up to negative 30, all right, which aren't good. Once again, I'll pause it for a second and come back when I have them. All right, I don't want to waste your time listing a bunch of factors. Alright, so those factors would be negative 8 and negative 25. Those multiply to be positive 200 and add to be negative 33. Alright, so I'm rewriting this as 20c squared, then the middle term as minus 8c plus negative 25c. You know me, how I like to have the plus in the middle for the grouping. Negative 25c. And then you got the plus 10. Right. Group the first two terms, group the last two terms. The first two terms have a common factor of 4c, leaving me with 5c minus 2. And then from the next two terms, the second group, I'd factor out negative 5, because the lead coefficient is negative. So I'll just, instead of plus, I'll just make minus 5. Right? I'm pulling out negative 5 from the second two terms. And then what would be left over would be 5c minus 2. And so we're finally left with 5c minus 2 times 4c minus 5. I would factor out the 5c minus 2, leaving me with the other factor of 4c minus 5. And there we go. There's the original expression, totally factored. And once again, check it, multiply these out. You should end up with the original statement. Okay, so that's what I'll enter. We have 5c minus 2 times 4c minus 5. All right, and please read your explanations. All right, same thing. Looks like the last question using this AC method. And so once again, I'll write this out and we'll do it. All right, so first, what's the greatest common factor of all three terms? It would just be 1. There's nothing going into all three of them. And now I have one of those quadratic trinomials. So let's see, AC be 14 times negative 12. Right, AC. And this should be 168. Negative 168. Pretty sure. Yeah, 144 plus 24. Yeah. Okay, so now we're looking for factors of negative 168 whose sum is negative 13. So I want the negative number to be bigger, right? So I would use negative 14 positive 12 instead of 14 and negative 12 have a sum of negative 2. Now that's not the right sum. I want a sum of negative 13. Okay. So let's see, we got. So again, I'll just come back when I find them. Right? I don't want to waste time making a whole list. You can make a whole list if you wish. All right. So those factors are negative 21 and 8. Those multiply to be negative 168, and they would add to be negative 13. which is what I want, right? So rewriting that expression, we have 14z squared, and then I'm rewriting the middle term, right, the negative 13z, using this pair of factors as minus 21z plus 8z. And then we have the minus 12. Now I can do grouping, first group plus the second group. The first half common factor is 7z. That would leave me with the other factor of 2z minus 3. Plus the second half, the second group, they have a common factor of 4. And the remaining factor there would be 2z minus 3 as well. And these two products have a common factor of 2z minus 3. So I pull out 2z minus 3. And the other factor after removing that would be 7z plus 4. So we have 2z minus 3 multiplied by 7z plus 4. And don't forget to check it, right? Multiply these, see if you get the original back, and you should. And just be aware that you're typing in, z's instead of x's. Right? So first factor 2z minus 3 times 7z plus 4. Okay. And that should be it for that objective, and the objectives in that heading. Right? So now I have two objectives left, and they were under the heading of factoring special products. All right. There's factor differences of squares, and the other one is sum or difference of cubes, special products. Okay. And so this first one's on differences of squares. Now, here they're actually telling us, they're giving us instructions saying factor, but if the expression is not factorable, which can happen, then enter the original expression. Right? Now, if a polynomial is not factorable, they would call that polynomial prime, just like a prime number can't be factored any further. But here we're not asked to write the word prime or anything. We're just, if it's prime, just write the expression again. All right, so let's write this out, and I'll do it on some paper. All right, so this objective is about factoring differences of squares. All right, difference of squares. Which take on the following form: something squared minus, right, difference, and then some other expression squared. If you're seeing anything like this, you can break it apart. You can write it as a product, and that product would be the product of a minus b multiplied by a plus b. All right, so whatever expressions are being squared are the a and b, and those go here and here. A minus b times a plus b. And again, you can check this out by multiplying, distribute the a to the a plus b, distribute the negative b to the a plus b, and combine the like terms, and you'll end up with just a squared minus b squared. All right, so here I do have a difference. Now, first thing is you look for common factors, right? Now, these two terms do have a greatest common factor of 3. 3 goes into 12 evenly, 3 goes into 147 evenly. So first I'll pull that out. And when I remove a factor of 3, what's left over would be 4 in the first term minus 49z squared in the second term. And technically you could also pull out a negative 3 if you like having a positive coefficient on the z squared. But you don't have to here. Right? They're not asking for that. Now let's focus on this. Now let's focus on the 4. I'll write it over here. 4 minus 49z squared. So you see I have a difference of two terms. So kind of like this. And the question is now, is the first term before the subtraction symbol a perfect square? Well, yes, it is. It is 2 squared, isn't it? Minus, and then is this part of the term after the minus sign also something to the second power, some perfect square? well, yeah, 49 is 7 squared, and then, z squared is just z squared. You could take the expression 7z and square it. 7z times 7z would be 49z squared. So I have exactly the same thing as I wrote up here. I have a difference of 2 squares. 2 squared minus 7z squared. So the 2 acts like the a. The 7z acts like the b. So this would factor to a minus b, 2 minus 7z, times a plus b, times 2 plus 7z, or 7z plus 2. And don't forget the 3. All right. So we can factor this. It is a difference of perfect squares. So this original expression, I pulled the 3 out, so that was there, and then the factors of 4 minus 49z squared are again 2 minus 7z and 2 plus 7z. And you can write these in the other order as well. You can write a plus b times a minus b 2, and it's the same thing. All right, there you go. And then once again, multiply it out. If you're multiplying properly, you should end up with the original expression, so don't forget to check your answer. Alright, so that's what I'll enter. Alright, we have the factor of 3 times, and then 2 minus 7z times 2 plus 7z, and that should be fine. And just don't forget you're typing z, not x. Just pay attention to the letters and read through your answer explanations. Alright. The next one is on a sum or difference of cubes, which again I'll write out the little formulas for that. Right. So I'll write this problem out, and we'll come to it on a piece of paper, and I'll talk about sums and differences of cubes. Alright, so this expression we're given here is a difference of 2 terms. And if you have a 2-term polynomial, the only way you're going to be able to factor it, except for the GCF, is if it's a sum of cubes, a difference of cubes, or a difference of squares. Right, that's the only way you're going to be able to factor over the integers when you have a sum or difference of 2 terms. So notice the third powers here. If your exponents are multiples of 3, chances are you have a difference of cubes, or if this was a plus, a sum of cubes. So first we'll talk about the difference of cubes. Well, I'll just put both. Difference, sum of cubes, of 2 cubes. Alright, so if you have something cubed minus, we'll start with the difference, minus something else cubed, so a cubed minus b cubed, you will be able to factor this. You can write it as a product, break it up. The first factor is pretty simple. Just drop the cubes. The first factor will be a minus b. Alright, it's the second factor that's a little trickier to remember. Just think about what would happen, what you would need when multiplying. If I multiplied a by something, I want a cubed, that would have to be a squared. So the first term in this second factor is a squared. Then the next sign is the opposite sign of the first factor. I know it's a lot that I'm saying here, but if this is a minus here, the next sign you're writing is a plus sign, so a squared plus. Then what happens is, in this second factor, there will be 3 terms. The power of a decreases, and the power of b increases. So the next term, you had a squared, now you have a to the first. You had no b, so you have b to the first here. So plus ab. And then the last term has the same sign. The last term always has the plus as well. Plus. And then again, the power of a decreases, the power of b increases. So a squared, a to the first, no a, no b, b to the first, b squared. And again, so that way when you're multiplying, you're going to get the minus b times b squared, giving me the minus b cubed. And all the other terms you get will cancel out. You'll have a cubed, and then plus a squared b, plus b squared a, and then minus a squared b minus ab squared, and those ab squared and b squared a will cancel, and then you'll have a cubed minus b cubed left over. All right, so this is a difference of cubes, and a sum of cubes, I'll just put in a little different color here, put the little plus sign underneath. If you have a cubed plus b cubed, that'll factor to a plus b times, and then the other factor will be a squared minus ab, and still plus b squared. The last sign is always a plus. All right. So again, I'll refer back to these when we get to other problems as well. And same thing with the difference of squares. I'll refer back to the difference of squares formula. So look at the expression we're given here. I do have something cubed. All right, they already gave this first expression, x plus 1 to the third power. So x plus 1, right, x plus 1 acts like the a, minus, and then 64y 64 times y to the third, that's 4y to the third, right? 4y times 4y times 4y would be 64y cubed. So 4y is being cubed to give me that second term. So I do have a difference of cubes, and like I said again, the x plus 1, this quantity x plus 1, that's acting like the a from my little formula over here. And then this 4y is acting like the b. So just go through the formula and replace all the a's with the quantity x plus 1, and all the b's with the quantity with just 4y. Alright, so the first factor is a minus b. So it'll be x plus 1 minus 4y. There's really no need for the parentheses on the x plus 1 there. Times, and the second factor is a squared, right? So the quantity x plus 1 squared, then again with a difference of cubes, right? Like we have here, we have a difference of cubes. You got a minus in the first factor. The next sign you write is a plus, right? So plus, then ab, x plus 1 times 4y. Then the last sign you write is always a plus, right? Plus, and then b squared will be 4y squared, and sorry about the squiggle coming through there. But I just went through this formula here with the minus, all the top signs, minus, minus, plus, plus. Replaced every a with the quantity x plus 1, and every b with the 4y. Alright, so now we simplify. Actually, let me take this down here. So the first factor is just x plus 1 minus 4y. There's nothing more to simplify there. All right. The second factor, we can multiply some stuff out here. X plus 1 squared is x plus 1 times x plus 1. That'd be x squared plus 2x plus 1. All right, that's x plus 1 squared. Then the second term, distributing the 4y, taking 4y times x plus 1, we'd have plus, 4xy plus 4y. And then the last term, 4y to the second, 4y times 4y would be 16y squared. And none of these terms are like. So this is it. This is a pretty long one, but this is it. This is the first factor, x plus 1 minus 4y. The second factor is this, x plus 1 squared, or x squared plus 2x plus 1, plus, then 4y times x plus 1, which would be 4xy plus 4y, and then plus 4y squared, which would be 16 times y squared. Alright, so I'm going to type all this out. Now, they might take it this way. We'll see in a second here when the answer explanations come up. But I'm going to type in this ln 1 just because it's, everything's all simplified. Alright, so the first factor, x plus 1 minus 4y. Second factor, x squared plus 2x plus 1 plus 4xy plus 4y plus 16y squared. All right. And submit. Great. All right, so you see you can. All right, looks like you can just keep things, the x plus 1s in parentheses. That is good to know. All right, that would have saved me some typing. All right, but again, please read through the answer explanation and see how they want things. Now, they totally took my thing because it was equivalent. All right, I mean, yeah, it's longer and more writing, but it is equal to what they have, which is fine. All right. Next one is another sum or difference of cubes. This time looks like a sum of cubes. See the plus there? Alright, so really no different. Alright, no different except for, you got a plus instead of a minus. So again, I'm going to write this out, pull it up on some paper. Alright, so I've got the little formulas I wrote out earlier here in the upper right corner of the page. But this time I have the plus sign, right? It's something to the third power plus. Now this I have to write as something, one expression to the third power, right? Right now the v is just to the third power, not the 8. So this is, the quantity u plus 2 to the third power plus, and then 8 is 2 cubed. So this is 2 times v to the third power, right? 2v times 2v times 2v. Would be 8v cubed. Right. And so, this u plus 2, right, this quantity u plus 2 acts like the a from my formula. The 2v acts like the b. Right? So I'm just going to go through the factorization here, the factors, and replace a with the quantity u plus 2, and all the b's with 2v. Alright, so again, the first factor is, a plus b, sorry, pluses. I'm using the blue guys, right? So a cubed plus b cubed would factor to a plus b first, right? So u plus 2 plus b, so plus 2v. Right, there's a plus b. Times, and then a squared, so the quantity u plus 2 squared. Then minus, right, with the sum of cubes, that's a plus, this is a minus a times b, so u plus 2 times 2v, and then plus again plus b squared. Let's keep this over here. Plus b squared, so plus this 2v to the second, and close parentheses, that's all the one factor. So this factor, a plus b, this factor, a squared minus ab plus b squared. All right, and then I'll simplify again. I know you can leave the u plus 2, it looks like, in parentheses, but I'm still going to multiply things out because I don't like the look of all these parentheses. So the first one's just u plus 2 plus 2v, right? There's no like terms there. That's as simple as that gets. So the first factor is that. Second factor. Now the a squared, u plus 2 squared, that'd be u squared plus 4u plus 4. Remember, you're doing u plus 2 times u plus 2 in foiling. This next one, you're distributing the negative 2v, right? The negative 2v to the u plus 2, not just 2v, but there's a minus here. So negative 2v times u, that'd be minus 2uv. Then negative 2v times 2 would be negative 4v. And then we have plus, and then 2v squared, 2v times 2v would be 4v squared plus 4v squared. Right? And none of these terms are like, so that's as simple as that gets. Right? So I know it's long again, but this is how I'm going to enter this. Right? The first factor and this whole ln second factor. And again, you can check by multiplying this out. It'd be crazy. It would be a long check, but you distribute the u to all these 6 terms over here, distribute the 2, distribute the 2v, and combine like terms, and you should end up with something equivalent to the original. Right? If you were to multiply out u plus 2 cubed. Right, but I leave that to you. Alright, so that's what I'll enter. Just remember it's u's and v's. So the first factor is u plus 2 plus 2v. Second factor, u squared plus 4u plus 4 minus 2uv minus 4v plus 4v squared, and that should be it. Right? Lots of type in there, but that should be good. Wonderful. Again, please read through the answer explanations. Okay, next one. It's a difference of squares, right? Difference of square pattern. So again, they're saying at the bottom there, if the expression is not factorable, just write the original expression, right? Because it'll be prime. You can't factor it any further. All right, so again, I'll write this out and we'll take a look at it. All right. So first, again, before you do anything else, greatest common factor, right? Do all the terms have some common factor? I notice a u. Also, 36 and 64 have 4 as a common factor, so 4u. So I'll pull 4u out. And the remaining factor would be 9m squared plus 16. That's it. All right. So now we focus on this one. Can this 9m squared plus 16, can that be factored any further? Well, you might be thinking, hey, 9m squared plus 16. That 9m squared, that's a square, right? 3m to the second. And 16 is also a perfect square. That's 4 squared. And then you might think, oh, 3m plus 4, 3m minus 4. But remember, that a minus b, a plus b factorization only worked for a difference of squares, subtraction. This would be like a squared plus b squared. This is a sum of squares, not a difference of squares. And a sum of squares can't be factored any further over the integers. I know I say every time, so that the coefficients are integers. Can't be factored. Please understand this. All right. So yeah, you're like, oh, the first term is a square. Boom. The second term is a square. Great. So I can factor it. No. It's got to be minus. If this was 9m squared minus 16, then you could factor it. But being that it's 9m squared plus 16, it can't be factored. It's a sum of squares. You're done. That's as factor. So pulling out the greatest common factor is as far as I can go. So this is it right here. This is how this polynomial will factor. 4u pulled out times the quantity 9m squared plus 16. But please know that a sum of squares can't be factored. Only a difference of squares. Okay. All right, so back, what I'll type in is, again, just pulling the GCF out, just pulling that 4u out. 4u times, and then 9m squared plus 16, and that's as broken down as that will get, as factored as that will get. Make sure I type the right letters. Great. See at the very end there, they're saying a sum of squares does not factor. So be careful. All right. So we're given another thing with possibly a difference of squares pattern. Let's see. So I'll write this out again. So once again, the first thing you're looking at is there a common factor to both terms, which is obvious here, 49. So you pull that out first. And then when I remove this common factor of 49, what I'm left with is just y squared minus x squared. And this is definitely a difference of squares. I'm hoping you see this, right? I'll just put diff of squares. All right, the only difference is, instead of a squared minus b squared, it's, y squared minus x squared. So y is like the a and x is like the b. So this will factor to y minus x times y plus x, or y plus x times y minus x. It doesn't matter, right? So we got the 49 that we pulled out earlier, and then this difference of squares, y squared minus x squared, would factor to y minus x times y plus x. And this now is as factored as that expression will get, right? But always first pull out the GCF, right? And then see if you can factor anything else any further, which I could here because we had a difference of squares. Now remember, be careful. If that was y squared plus x squared, you'd stop. You can't factor sums of squares. Alright, so let me enter that. So we have 49 pulled out, the GCF, and then you had the factors of y minus x times y plus x. And that's what I'm entering. Alright. Hooray, hooray. Okay. And so still in a problem that may have a difference of squares in it. Alright, so what I'm noticing here, I'm just going to talk this one out because notice this is a sum. The greatest common factor of these terms would be 16x. They both have 16x as a common factor. And when I pull out 16x, the factor remaining would be z squared plus 4. Right? And I'm leaving it that way. Because again, that z squared plus 4, that's a sum of squares. Z squared plus 2 squared, a sum of squares. And a sum of squares can't factor any further. So the only thing that would need doing here is pulling out the GCF. And that's all you could do when factoring this. Great. So again, I hope that makes sense. The whole difference between a sum of squares can't be factored and a difference of squares can. Now that's opposed to sum of cubes, difference of cubes, right? A sum of cubes and a difference of cubes can both be factored, right? There was a formula for both, just the signs changed, like little pluses were minuses became pluses and pluses became minuses and stuff like that. All right, so looks like here I have a sum of cubes, right? See the plus in the middle. So once again, I'm going to write this out. All right, so I'm hoping you're seeing the sum of cubes here, right? The first part before the plus sign is, r plus 6 to the third power plus, and then 27 s cubed, that's 3s to the third power. 3s times 3s times 3s would be 27s cubed. So in my little formulas here, and here are the sum of cubes, difference of cubes. Again, I have a sum of cubes, so I'm looking at the plus, the lower signs. A cubed plus b cubed factors to a plus b. So the first factor will be r plus 6 plus 3s times the second factor is a squared. So r plus 6, right, the quantity r plus 6 squared minus, right, for the sum of cubes, then you have minus ab, so minus the quantity r plus 6 times 3s minus ab, and then plus b squared plus the 3s to the second, and then close parentheses on that factor. And then, I don't know, I personally like multiplying stuff out so that there's much fewer parentheses to, mess with the i's. This is r plus 6 plus 3s, that first factor. Second factor, r plus 6 to the second power, that'd be r squared plus 12r plus 36. All right, take r plus 6 times r plus 6. Then the minus ab, you're distributing the negative 3s to the r plus 6, that'd be minus 3sr, or 3rs. Then negative 3s times positive 6 would be minus 18s. And then plus, 3s squared would be 9 times s squared. And this is what I'm going to enter right here, that factorization. All right, so first factor, r plus 6 plus 3s, close parentheses, times the second factor, r squared plus 12r plus 36 minus 3rs minus 18s plus 9s squared, and then close parentheses, and I'm done with that one. Again, very similar to previous problems I've done with this objective. All right, just different letters. Again, please read through the answer explanations, and if you want to enter things the way they do, they kept the r plus 6 in parentheses, that's totally fine as well, without multiplying it out. All right, then my final question here is on that same objective, factor a sum or difference of cubes, and it's pretty much the same thing, but just a difference of cubes now. Okay. So once again, I'll write this out, and we'll go to the difference of cubes pattern and fill it in. All right, so this first term before the minus sign is obviously a cube, right? This quantity p minus 2 to the third power minus, and then 125 times q cubed would be 5q to the third. 5q times 5q times 5q would be 125q cubed. All right, so like I said, this p minus 2, this acts like the a in my difference of cubes formula. The 5q acts like the b. And we're doing the top signs, right? A cubed minus b cubed factors to a minus b, right? So p minus 2 minus 5q times, and then the other factor be a squared, so the quantity p minus 2 squared, plus ab, so plus p minus 2 times 5q, and then plus b squared, plus 5q to the second. All right, so this time I actually will, just for this last one, I'll write it the way they've been writing it. So the first factor is just this, p minus 2 minus 5q, totally fine. Second factor, I'll just leave this as p minus 2 squared plus, and then throw the 5q in front. 5q times the quantity p minus 2 plus, and then actually multiplying this out, 25q squared. And I'm going to enter it this way. This is the way they've been entering things in the answer explanations. So I'll try entering it this way and see if they take it. And I'm sure they should, because it's equivalent. All right. So first factor, set of parentheses, we have p minus 2 minus 5q. And close parentheses, new set of parentheses, next factor. Then I got the quantity, p minus 2 to the second. Then plus 5q times the quantity, p minus 2. And then plus 25q squared, close parentheses. All right, let's see, they should take this. This is also equivalent. Wonderful. All right, and that should be it for all 6 objectives in this now. The assignment complete. So yeah, that was a bit of a longer one, right? This video is like 2 hours long, and hopefully you're looking in the description of the video at the timestamps, and you can bounce around from question to question in the timestamps if you don't want to look at the whole video. Probably should have mentioned that at the top of the video, huh? Anyway, just please know that the version of the assignment I just went through isn't going to necessarily be the exact same version you see, when you work on it yourself. but the objectives are the same, the types of questions are the same, the way I did them would be the same as the way you did them. You should do them, you should try doing them. So I'm hoping that watching me go through all this helps you out in some way when you're working on the assignment yourself. All right, and thank you very much for watching.